You're welcome to Excellent Simplified Tutorials.
So today we'll be looking at indices. And indices, if you hear the word index, what comes to your mind? When you hear index, what comes to your mind? Power, right? Please, mathematics is not cramming, just understand. Index, you are talking about the power, is it not? Now, in indices, or when we talk about index notation, we're going to look at how you can shorten group of numbers. For example, if you have something like this, 2 times 2 times 2 times 2 times 2. This is long, right? The simplest way of writing this, think this is the same thing as 2 raised to power how many? 2, 3, 4, 5. Raised to power 5, right? Now this is the index notation. So we are shortening the product of numbers. Do you get that? Are we together? So in indices, this is basically in index notation, this is basically what you're doing. You just shorten the product of numbers. If you have something like this, 2 times 2 times 3 times 3 times 2. How do you do this? If you want to write this in index sum, index notation, how do you do it? 2 raised to power 3, right? 1, 2, 3. So you just take the ones that are the same. 2 raised to power 3 times what? 3 raised to power 2. So this is basically when we talk about index notation, this is what we mean. Is this okay? Okay, just for reference, you can write one of these examples and we go on to the laws. Now, if you have something like this, 2 raised to power 5. This 2 is called the what? This 2 is called the what? The base, right? Good. It's called the base. Why the 5 is the what? Power or what? If you don't call it power, you call it what? No? No. Or the index. The power or the index. So 2 is the base and 5 is the power in this case here. Laws of indices. Laws of indices. So there are basically 8 laws of indices. Let's take the first one. Multiplication law. If you have something like this, 3 raised to power 3 times 5 raised to power 4. Okay, let me use the same base. Times 3 raised to power 4. Do they have the same base here? They have the same base, right? Now, multiplication law of indices states that if you are doing something like this, an operation like this, the bases are the same, and this is multiplication. What do? You just take one of the base. And what do you do to the powers? You add the powers. If this is multiplication, you add the powers. So we have 3 plus what? 4. This will give me what? 3 raised to power what? 7. And you agree with me that this is true, because if you look at this, 3 raised to power 3 is the same thing as 3 times 3 times 3, right? Times 3 raised to power 4 is 3 times 3 times 3 times 3. And when we looked at index notation, we said to shorten this whole stuff here, we can just take one and we count 1, 2, 3, 4, 5, 6, 7. Still the same thing. 3 raised to power 7. So the multiplication law says that if you have 2 bases that are the same and multiplication is separating them, what you do is you add the powers. Is that okay? So generally you can write a raised to power 3 times a raised to power 4 equal to a raised to power 3 plus 4. So generally you can, or you use, okay, for simplicity, let's use x and y, making it general. So a raised to power x plus y. That's the first one. Is there any equation on that? Please, for you to add the power, yes, the basis must be the same. Yes, if you have something like this, 3 raised to power 2 times 5 raised to power 3, you cannot apply it here. You cannot apply it here. What if you have something like this? Just write this and do it for me. You have something like this: 3 raised to power 2 times 4 raised to power 5 times 3 raised to power 3 times 4 raised to power 2. Solve this for me very quickly. Second one, division law. They are actually 8. We'll look at the 8, then we start solving exercises. I'll solve one, you solve one for me. Division law. All right, so for example, let's look at 2 raised to power 9 divided by 2 raised to power 3. Now, if you look at this, if here was multiplication, what will you do? You add, right? But you know when they say something is a dividend and a divisor, if I have something like this, 5 over 2, which one is the divisor and which one is the dividend? The divisor is 2, right? And the dividend is 5. Good. Now, in the division law, if you have something like this, all you need to do is, since the bases are the same, you just take 1, and what do you do to the powers? You subtract. So 9 minus 3, which is what? 2 raised to power what? You agree with me that 2 raised to power 9 is the same thing as 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. All over 2 raised to power 3 is 2 times 2 times 2, right? And in primary school, you say this cancel this, this cancel this, this cancel this. We are left with 1, 2, 3, 4, 5, 6, which is the same thing as 2 raised to power 6, right? So you see that this is correct. Do you understand that? So this is the division law. So in general, we can say a raised to power x divided by a raised to power y equal to a raised to power x minus y. Are we following? All right, so you can write that down. Let's go. So if you have something like this, please look up. If you have something like this, a raised to power 3 or raised to power 2. They are in powers. This one is raised to power 3 and again raised to another power. So in this case, what do we do? Do we add the powers? What do we do? We multiply, right? You know, this is saying, this raised to power 2 here is saying everything in this bracket is appearing 2 times. Is it not? So this thing is just like saying a raised to power 3 times a raised to power 3. Is it not? We are back to multiplication law. What do we do to the powers? We add, right? 3 plus 3 will give us what? You get now. So since this is multiplication, we add the powers, right? A raised to power 6. Instead of going through this long route, why not just multiply this? So we can have a raised to power 3 times 2 will give us what? 6. You see, we still got the same thing. Still got the same thing. So anytime you have something like this, power of powers, you multiply, and you get your answer. We'll apply every bit of this law when we start solving. So generally, we can say a raised to power x raised to power y equal to a raised to power x times y, or you just say xy. The fourth law, product power law. Product power law. Now you take note of this one very well because most persons will always make mistake here. If you have something like this, for example, 3pq all square. You know this is same as 3 times p times q, right? All square. Now, please look up. This square applies to everything in the bracket here. Some persons will just come and say 3pq square. This is very wrong. This square outside the bracket here applies to everything in the bracket. So this is the same thing as 3 square times p square times q square. Do you get that? So anything outside the bracket here, square here, applies to everything in the bracket. So we'll be having 3 square is what? 9, right? So we'll be having 9. 9p square q square. Do you understand? Zero index law. Zero index law. We already know that index means power, right? It is a basic principle that anything raised to the power of 0 is what? Is 1, right? So if you have a raised to power 0, it is what? 1000 raised to power 0 is what? 100 million raised to power 0 is what? In fact, give raised to power 0 is what? 1. Anything at all raised to power 0 is 1. Because some person usually say anything raised to power 0, 1. No, 0. No, it's 1. Anything raised to power 0 is 1. Alright, so that's that. Number 6. Negative index law. If you are done with that, just look up. We already know that index means what? Power, right? Power. Now, negative index. If you have something like this, 2 raised to power 6 divide by 2 raised to power 9. Back to the second law, division law now. This is the same thing as 2 raised to power what? 6 minus what? 9, right? Minus, because here is division, is it not? So we'll be having 2 raised to power 6 minus 9 is what? Minus what? Minus 3, not 3, minus 3. Now we've gotten a negative index, negative power. When we have a negative power like this, what do we do? Now, before I tell you what to do, now look at this. Let's come back to this place. 2 raised to power 6 is the same thing as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, right? All over 2 raised to power 9 is 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, now, and we know to divide, this can cancel this. This cancels this. This cancels this. This cancels this. We are left with how many up? None up, right? All over what? How many down? 2 raised to power 3, right? But we cannot just do rule line like this and say 2 over 3. It's supposed to be what? 1 all over 2 raised to power 3. So anytime you have a negative index like this, we just take the reciprocal. Reciprocal means 1 over. Take the reciprocal all over 2 raised to power the positive index. So anytime you have minus a power, you take 1 all over the positive. Let me see if you understand what I mean. Do this for me. Work on this for me. This will not take you 2 seconds. Let me just see if you get the concept. If you have something like this, 3 raised to power minus 8. We said all you have to do is take the reciprocal 1 all over. You remove the minus now, 3 raised to power 8. That's all. Some persons will make this mistake of writing it this way, 3 raised to power 1 over 8. Yes, I've seen it several times. 3, that is the 1 over is only for the power. No, it's not done that way. It's 1 all over the whole stuff here. Do you get that? So don't make that mistake of doing this. Can we move on to the next law? Law number 7. Number 7. Root power law. Root power law. Root power law. If you have something like this, a raised to power this, a raised to power that, how do you do it? Now, this is 1 over 2, right? Raised to power 1 over 2. This is the same thing as, yes ma'am, yes ma'am. This is the same thing as saying square root of what? A, right? Anything you have down here, 1 over 2, anything you have down here, you take the root. That will be the root. This is what I mean. Let's use this one. You know, it's not good to write it this way. Whether we put this 2 or not, we already know a square root, right? Now, here, this one will be what? Cube root, right? That is anything you have here, that will be the root. Anything you have down as the denominator will be the root. Do you get that? This one will be what? 4th root, right? Do you get the principle? Do you get? Joyce, Felix, do you get? You get it, right? Okay, so this is how it runs. So you can write this. But what if we have something like a raised to power 2 over 3? That is when we come to the next law. So write this one down. Number 8. The last law here, fraction index law. Fraction index law. Fraction index law. Let's use this 3 to illustrate this. In this other one, we are just having 1 over 2, 1 over 3, 1 over 4. What if you're having 3 over something? What if you're having a fraction like this? Now, if you look at this, it still works with the same principle as this. Just assume you are not seeing this 3. This, I think anything down from here, anything down will be the root, right? Same thing applies here. Anything down, the denominator of the power will be the root. So here we have what? Square root of what? A, right? Is it not? Then this one up here will be the power. Do you get? Let me take that again. A raised to power 3 over 2. Is it not? Now, our A remains there. From the 7th law, we said anything down becomes our root, right? That was why here was square root, here was cube root, here was 4th root. Anything down becomes our root. Here, the same thing applies. Anything down here is our root. Like here, square root, because here is 2. But this 3 up here was 1. So we have nothing to do about it. But here is 3 now. So we will take the cube of it. Here now, we have what? Cube root, right? Cube root of A, right? All raised to power what? 4. Is it not? Do this last one for me. Write this 2 and do this last one for me before we take exercises. I want to actually check if you understand all the 8 laws we've talked about. So the first one here says 8 raised to power 1 over 3. Now you agree with me. Which law is this? Which law are we going to apply here? You said? No. Root power law, right? So now this is the same thing as what? This is the same thing. 8 raised to power 1 over 3 is what? Cube root of what? Cube root of 8. And cube root of 8 is what? 2. Now when they say cube root, what does it mean? Why, in fact, why is cube root of 8 equal to 2? 2 into 3 places, right, will give us 8. 2 times 2 times 2 will give us 8. 3 places. So what into 3 places will give us 8? That's what they mean. What into 3 places will give us 8? That is that. So this is our answer. 2. B. 81 raised to power 3 over 4. Now this is what root? 4th root, right? So 4th root of 81 all raised to power what? All raised to power what? 3, right? The 4th root of 81 is what? 3. 3 times 3 times 3 times 3 will it give us? With 3 raised to power 4 give us 81. Is it? So then 3. So 3 raised to power what now? And 3 raised to power 3 is what? 27. Do you understand? Do you know how we are? Do you understand how we arrange this? Good. Now, the 4th root of 81, what will you multiply 4 times? 4 times, that will give you 81. What will you multiply 4 times that will give you 81? 3 times 3 times 3 times 3. 3 times 3 is what? 9, right? 9 times 3 is what? 9 times 3 is what? 27. 27 times 3. That was how we have this 3. You can multiply 3 4 times to give you, like, into 4 places to give you 81. Then all raised to power 3. So 3 raised to power 3, we have our 27. So that's the answer to that question. Is that okay? You said? Yeah. 3 and 3 cancels 3. That's a very sharp one also. Do you understand what he's saying? That in this number 1, you know, this is the same thing as 8 is the same thing as 2 raised to power 3, right? 2 raised to power 3 is 8, right? Raised to power 1 over 3, is it not? And remember that the product power rule, you multiply the powers, right? So you have 2 raised to power 3 over 3, is it not? 3 over 3 is 1, right? 2 raised to power 1 is equal to what? 2. We still got the same 2 here. So that is a very quick one also. Let me take that again. Do we understand the basic method we use here? Yes. Good. Now, 8 raised to power 1 over 3 is the same thing as 8 is the same thing as 2 raised to power 3, right? 2 raised to power 3 will give us 8, is it not? Yes. 2 raised to power 3 is the same thing as 2 times 2 times 2, which is 8, is it not? And it's raised to power something. This is our 8. This stuff here is our 8 raised to power what? 1 over 3, is it not? And remember the product power rule, that when you have 2 powers like this, you multiply 2 of them, is it not? So this is the same thing as 2 raised to power 3 times 1 over 3. And 3 times 1 over 3 is the same thing as 2 raised to power 3 over 3, right? Which is 2 raised to power 1. And 2 raised to power 1 is 2. So we have the same thing as this. So anyone that is okay with you, perfect. In this other case, okay, in this other case, you can still do something like that. Let's try. 81 is what raised to power what? 3 raised to power 4, right? 81, 3 over 4. This is the same thing as 81 is 3 raised to power 4. And we already have power 3 over 4, right? And the powers are multiplicative. So we have 3 raised to power 4 times 3 over 4, right? This is the same thing as over 1. 4 can cancel 4, is it not? We are left with 3 raised to power 3, right? 3 raised to power 3 is what? 27. The same thing. So any method that is okay with you. Mathematics is dynamic. You are not stuck to one answer, like one method. You have the same answer, but you can use different methods. C says 27 raised to power what? Minus 2 over 3. What law are we going to apply here? Negative power law, right? Negative index law. And the negative index law, if you have something like this, this is same as what? 1 all over what? 27 raised to power what? 2 over 3. Is it not? Is it not? We will apply the next law. This is the same thing as 1 all over 27 raised to power 2 over 3 is the same thing as what? Root what? Root 27, cube root of 27, right? Or square. Is it not? Here we can continue to say 1 all over cube root of 27 is what? 3, right? Because 3 times 3 times 3 will give us 27. So 3 raised to power 2. So we'll be having 1 all over what? 9 as our answer. If you don't want to go that round from here, if you don't want to go that way from here, you can just use 1 all over 27 is the same thing as what? 3 raised to power what? 3 raised to power 3, right? So you can use 3 raised to power 3 bracket 2 over 3, right? So from here you can have 1 all over 3 can cancel 3, right? So you're having 3 raised to power 2, which is what? 1 all over 9. So anyone that is short for you, go on. Basically, you can use this one very well when to find the cube root to give you some issues. You said? You thought it was supposed to be in brackets. Okay, this one. There's no problem. The next one, D, 64 raised to power 5 over 6. Believe everyone can solve this one now. There are two methods you can use, just like we've been using since. Yeah, this is the sixth root of what? Sixth root of what? 64, right? All raised to power 5. The sixth root of 64 is what? 2, right? 2 times 2 times 2 times 2 times 2 times 2. 6 times is 64. Is it not? So we'll have 2 raised to power 5, right? You can leave it like this. Or if you don't want to follow that way, from here, from here, 64 is the same thing as what? 2 raised to power 6, right? Raised to power 5 over 6, is it not? 6 can cancel 6, and I'm left with 2 raised to power 5. So in the exam, since there is no time, follow the shortest method. Do you understand this? Please, when I'm explaining, stop writing. When I'm explaining, stop writing. I'll always give you time to write. Nobody should be having issues with E now. 16 all over 81 all raised to power 3 over 4. In this case, what rule are we going to use? There are many methods you can use to attack this. What rule do we use here? Roots. Okay, let's go with the roots. This thing is reducible, you can reduce it. But let's go straight first. This is the same thing as what root? First root, right? Of 16 all over 81, right? All raised to power what? All raised to power 3. Is it not? Good. Now, how do we go about this now? The first root of 16 is what? 2. All over the fourth root of 81 is what? 3, right? All raised to power what? This will give me what? 27 over what? 8 over 27. Why? This thing is applying to everything in the bracket here, right? So this is what? 8. 2 raised to power 3 all over 3 raised to power 3, is it not? So 8 over what? 27. Now let's check if this is actually correct. Look at this. 16 is the same thing as what? 2 raised to power what? 4, right? All over 81 is what? 3 raised to power what? 3 raised to power 4, is it not? All raised to power 3 over 4. So if you don't want to solve it straight like this, you can reduce it here. So far. You're done. That's good. I like to hear that. Anybody that gets it right, you're rich in life. In solving this, we have P here, we have P here. We have Q here, we have Q here. Division law. This is the same thing as saying 2, 4, 5, P raised to power 3. Now, if you look at this, this is the same thing as divide by 5 P raised to power 5, right? This divide by this now. Or if you don't want to go that round, if I write everything out, this is the same thing as 2, 4, 5 times P raised to power 3 times Q raised to power minus 2, right? This one up. All over, this one down is 5 times P raised to power 5 times Q raised to power minus 6. Is it not? Good. We can divide 25 divided by 5. 245 divided by 5 is what? 49. So I can have square root of 49 times, now p raised to power 3. This is p raised to power 3 divided by p raised to power 5, right? So if it's coming up, it will be 3 minus what? Minus 5, right? Times, now this q raised to power minus 2. If this is coming up, it will be what? Plus 6, right? Because minus plus. So plus 6. Good. So we've reduced everything to this. Now who got it to this point? Okay, everybody. Yeah, good. Alright, so now from here, this is the same as square root of 49 times p raised to power 3 minus 5 is what? Minus 2, right? Times q raised to power what? Raised to power what? Minus 2 plus 6 is what? Give us what? 4, right? Minus 2 plus 6 will give us 4. Now this is square root. It's from here you're getting it wrong. Square root of 47 is what? 49 is what? 7, right? What is the square root of p raised to power minus 2? What is the square root of? Because this square root is affecting everything here. So what is the square root of p raised to power minus 2? Say 1 over p. 1 over p. Okay, let's take it this way. If you have something like this, p raised to power minus 2 is the same thing as 1 all over p raised to power 2, right? Is it not? Good. So what if I bring it this way? If you look at this, if I take the square root here, square root of 1 is what? 1, right? All over. Square root of p square is what? Square root of p square is what? P. How? Square root will remove square, right? So we have p. And 1 over p is the same as p raised to power minus 1, right? So from here, the square root of p raised to power minus 2 is p raised to power minus 1. Let me take that again. Where's my duster? We understand that square root of 49. Okay, let me break it down into segments. This square root of 49 times square root of p raised to power minus 2 times square root of p raised to power 4. Is it not? Good. Now, square root of 49, we already know is 7, right? Times square root of, this is the same thing as square root of p raised to power 1 over 2, right? Is it not? Times square root of q raised to power 4 is what? Q raised to power 2, right? Do you know how we got the q raised to power 2? Now, if we have square root of q raised to power 4, q raised to power 4 is the same thing as q raised to power 2 times 2, right? Is it not? This other square can cancel the square root. Remember, square removes square root, and we are left with q square. So, now back to this. So 7 times square root of 1 is 1 all over square root of p square is what? Since square will remove square root, we will be left with p times q square. Is it not? This is the same thing as 7 times p raised to power minus 1 times what? Q square. This is your final answer, but in the option you can see it arranged differently. You can see something like 7 q square all over p. Is this correct or wrong? Correct or wrong? Correct, right? Because it's 1 all over. Is it not? So anyhow they arrange it in the option. So right that, let's go to another simple one.